This is the second part of the OCR paper 5 from November 2022. So we're covering questions 11 to 21. Okay, so here is question 11. We're at 0.27, both of which are recurring, just in case you can't quite see there's two dots there, as a fraction in its simplest form. So we're going to start off by calling this x 0.2727, and it would carry on across the bit so you can see it. Okay, well, there are two things that recur. So there's only one number that recurs here. So say it was 0.22222, then I would times it by 10. Because there are two numbers recurring, I'm going to times it by 100. And it's going to become clear in a minute why. So I'm just going to put in here 100x is 27.2727 ... Okay, now can you see that then the numbers still line up after the decimal place? Because I've times it by 100. And what I'm going to do now is I'm going to take 100x, take away x. So that would be 27 take away 0, which is 27. And then I do 2 take away 2, 7 take away 7, 2 take away 2, 7 take away 7. So these match up and they all cancel out, and I'm just left with the 27. So I can say that 99x equals 27. Okay, so I'm going to divide by 99 on both sides, so I've just got x again. So x is equal to 27 over 99. Now I'm part way there at this point because I've got to simplify, so it's this bit here in its simplest form. Now I know both of these are in the 9 times tables. I might start with 3 if I don't spot it straight away, but both of these are in the 9 times tables. So 9 times 3 is 27, and 9 times 11 is 99. So it's 3/11ths. Okay, moving on to question 12, probability question. Fit all of that in, much as I can. Okay, so what this is showing is time taken for each of 160 students to complete a puzzle, and the time in seconds is across the top, these groups across the top. So we've got 20 to 30, 30 to 40, 40 to 50, 50 to 70, 70 to 90, and we've got 8, 0, 12, 30, and 10 on the end. So the first bit here says that Reese is working out that if two students are picked out random, what's the probability that both of them are going to take longer than 50 seconds, sorry. So it's these two groups here. So he's saying if I do 30 plus 10, that's 40. That's all the students that took more than 50 seconds, which is correct. It says the probability that one student took longer than 50 seconds is therefore, so there's 60 students, and I'm saying there's 40 of them taking longer than 50 seconds. So there's 40 out of 60, and that simplifies to 2/3. I've got no arguments here. However, I do have a problem with this line. The probability they both took longer than 50 seconds is 2/3 times 2/3, which is 4/9. Now, it does actually say explain the error in this method and write the correct calculation. Now, the reason being, if I take my first students here, so I've got 60 students to start with, and the probability that I pick one of them out as being over 50 seconds is 40 out of those 60. However, now I've chosen one of these people, I've now only got 59 people, okay, for the second pick. And if one of them already has taken longer than 50 seconds, I've no longer got 40, I've got 39. So the correct calculation is 40 over 60 times 39 over 59, or 2/3. You could simplify here, times 39 over 59. So that's the correct calculation. And the reason that you would give here the error is that the second fraction should be this, because it is a dependent event. These are dependent events. So if you think back to independent, meaning one doesn't have an effect on the other, which is what this calculation shows. So that would be, I pick the person, I send them back into the group, and then I repick. Okay, so it wouldn't change how many there were in the group. However, this is a dependent event because I'm saying I'm just picking out two people, so it's a bit like the counters in the bag. Do I replace or not replace between picking out the colours? So that's what that is getting at. It means these are dependent events. Okay, I'm going to keep this at the bottom now. because what it says is 2 students are picked at random from those who took 50 seconds or less. So that's 8 and 12 here. Just find the probability one of them took 30 seconds or less. That's 8. The other took more than 40 seconds. So the 40 more is 12. Okay, so let's move this out of the way so we can see now. So we've got the 30 or less, and we've got the 40 or more. We've got to find the probability that one of them took 30 seconds or less, and the other took more than 40 seconds. So we're picking out of 20 people here. Okay. Now, the options here, I could have somebody at the first one I can do is they can do 30 or less, the first person I pick, and then the second person was 40 or more. Or I could do 40 or more for the first person and the second person coming from the 30 or less group. So I've got 2 different options here. And again, this is going to be dependent events. So in the first one, I've got 8 people out of 20. And this is an and bit here, so it's going to be a multiply. So I'm picking, write it in the middle. Okay, so 30 or less and 40 or more, so 8 over 20 multiplied by the 12, so there's still 12 students. And then here, I'm going to have those, it'll only be 19 people because I've already picked one. Okay, I'm not going to work that out for a second. Then the 40 or more in this option, so 40 or more for the first pick would be 12 out of 20. Multiplied by, and then the second pick, if they're 30 or less, that's the 8 out of 19. Now, I can work these out separately and do the same, but essentially what I've got across the top is 12 times 8, 8 times 12, and across the bottom is 20 times 19, 20 times 19. So they're going to give me the same answer. I'm going to simplify this one. So 4s into 20 is 5. And 4s into 12 is 3. So 8 times 3 is 24. 5 times 19 is 95. Let's put that on there. And then I'll show you that this gives exactly the same once I've simplified it. So remember, with multiplying fractions, I can, on the diagonals, I can simplify if they've got common factors. So 8 divided by 4 is 2. 20 divided by 4 is 5. So times 2 is 24. 5 times 19 is 95. So I'm going to add them up. 24 plus 24 is 48 over 95, and it's an add this time because I am doing an or situation. So I could have done it by going 30 or less and then picking a 40 or more, or I could have picked 40 or more first and 30 or less second. Okay, so those are my 2 different ways of picking 2 people who were in those groups. Okay, so it's 48 out of 95. Now on to question 13. We've got points A, B, C and D on the circumference of a circle. Line AC intersects with BD at this point here. E, prove that the triangle AED is similar to triangle BEC. So if we're looking for similarity, the similar shapes are shapes that are maybe enlargements of each other. However, their angles will still remain the same. So what we're looking to prove is that there are 3 equal angles. That's the proof for similar shapes. Okay, now the first one is a little bit easy because we can see we've got vertically opposite angles here. So we know that AED, angle AED, I'm going to start with AED, angle AED, is equal to, the other way, BEC, so these 2 angles here, angle BEC, and that's the reason is they are vertically opposite angles are equal. So angles are equal. Okay, so you'll have to state your rules here. So there we go, that's the first one. So angle, these 2 here are equal because they are vertically opposite. Now the other 2 are going to be equal to these pairs here. So we'll put little stars here for those 2. those two are going to be equal because of the circle theorem. And the circle theorem is the same segment rule, so angles subtended from the same arc equal. And it's going to be exactly the same for these two here. So both of those have got the same reasons behind, and it's the same segment rule. So that would be angle DAE is equal to angle EBC, and I'm going to put these two together, and angle ADE is equal to ECB. You need to label all these angles with 3 letters. If you're going to label them with 1 letter, so angle at B, the difficulty here is this one, so this you're going to have to be much clearer with. You'll get away with it if you put angle B is equal to angle A, but you won't get away with it here. You have to be really clear, so it's better to use your 3 letters to show what the name of your angles are. And I'm going to state my rule here. So you could say angles in the same segment are equal, or you can go for the full one. Angles in the same segment are equal, or you could go for angles subtended from the same arc, but not angles subtended from the same chord. That's not the same thing. And my conclusion, this is the final mark. So you'll notice there's 3 marks. You're getting 1 for this, 1 for this, and the final bit would be for your conclusion, would be that they are similar. Because they have 3 equal angles. Equal angles. You can just say angle, 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 but like when you do the triangles. There we go. So AED is equal to BEC because they are vertically opposite. DAE is equal to EBC, and ADE is equal to ECB, and that's because angles in the same segment are equal. And then final mark, they are similar because they have 3 equal angles, 3 corresponding equal angles. Angle, angle, angle. Okay, let's have a look at question 14 now. Our question is about recognizing something here. So the number of bees in a colony is given by the formula. P, the number of bees, is equal to A times B to the power of X. That's a very small X, you can't quite make out there. Where X is the number of months after the start of July. Now, this formula here is what we need to recognize to answer the question. At the start of July, there were 25,000 bees in the colony. After 1 month, there were 23,500 bees in the colony. Find the value of A and the value of B, give the value of B as a decimal. Reading this, your first instinct is that I haven't got enough information to answer this. I have no idea what A and B would be. It's given me nothing to work them out. The only bits of information I've actually got is that we're losing 1,500 bees. Okay, so that minus 1,500 bees in 1 year. But what we should be understanding here is these kind of population ones with a formula. It's a little bit like the compound interest. So population here is decreasing. So this is like a compound interest. So A is going to be your starting value, which is 25,000. So that's the easy bit. So A is my starting value, 25,000. B, therefore, has got to be my percentage that it's changing by each year. So we've got to work out what the percentage is. Okay, so we know there's 1,500 bees disappearing in that first year. So we know there was 1,500 bees out of the 25,000 that we started with. Okay. Now, I'm going to simplify that fraction because, again, this is a non-calculator paper, so I haven't got a calculator to start working this out and then times it by 100. So I'm going to start by simplifying it down to 15 over 250. And then I can see that 5 is a factor of both of these. So 15 divided by 5 is 3. 250 divided by 5 is 50. Dividing by 5 here. And now to give me a percentage, if I put that over 100, so timesing by 2, 3 times 2 is 6. So it's telling me that we are decreasing by 6%. Okay, so I wouldn't put 6% here though, because if I did 25,000 times 6 cents, what I'd end up with is 1,500. I want to end up with 23,500. So it's 100% take away 6%, which is 94%. Now you could have just worked out 23,500 over 25,000, but I think that's a little bit more of a difficult calculation to get over 100. This is a lot easier. So 94% is my amount, is my percentage for B, but it wants it as a decimal, so it's 0.94. So my two values are 25,000 and 0.94. So question 15 is sort of your index laws, your roots, your surds questions. So if I look at this one, root 3 times root 15 to simplify. Now there's no factors of these that are square numbers, so I can simplify them. So if I remember back to my rules, that the square root of AB is equal to the square root of A times the square root of B. So they are interchangeable. So at the moment I've got this side. Okay, so root 3 times root 15 is the same as the square root of 3 times 15. So I can change this now to the square root of 3 times 15 and see if that helps me more. 3 times 15 would be 45. And if I look at factors of 45, 1 times 45, 5 times 9 springs to mind, and 9 is a square number. So splitting it back up, so going back to this stage, the square root of 45 is, 5 times the square root of 5 times 9. Split them up. Square root of 5 times the square root of 9. Well, I know the square root of 9 is 3, and that leaves me with root 5. So I've got 3 root 5. Next one, 40 over root 15, rationalise my denominator. So if I've got 40 over root 15, then the trick to this is to times it by root 15 on the top and the bottom. Okay, this is timesing by 1, so I'm not changing the value of it, but what I am doing is cancelling out this root here. So 40 times root 15 is 40 root 15. It's the easy bit. Root 15 times root 15 is, so it's a bit like saying the square root of 4 times the square root of 4. It's going to leave you with 4 because that'd be 2 times 2. So the square root of 15 times the square root of 15 is just 15. It's like square rooting then squaring again. And then I can now simplify both of those. They will both divide by 5. So 40 divided by 5 is 8. And I keep the root 15. 15 divided by 5 is 3. And that would be my answer. 8 root 15 over 3. Okay, final one. Write this a bit bigger. 27 to the power of 4/3. I always imagine this a bit like this is my line of soil and this is my flower at the top. And this is my root. So this would be my root under the soil. There's my soil line. And this would not be my flower, but my power. Okay? So when I do this, I'm going to do the cube roots of 27 to the power of 4. So the cube root of 27 is 3. And 3 to the power of 4 is the same as 3 squared times 3 squared. 9 times 9, which is, moving it across, 81. Okay, it isn't asking me to give my answer in index form or anything like that, so it doesn't want the answer of 3 to the power of 4, it actually says work out, so that's telling me there that I need an actual answer. If it said, simplify this, giving it your answer in index form, this would be your answer. Okay.